start with one of our questions right away. So number 3 here is the starred problem. Go ahead and work on solving that, and then we'll get into our lesson. We only have a couple slides to get through today. This should be relatively short, but we do have the angle bisector theorem to deal with today. And again, it's about setting things up proportionally. The big thing to recognize here is the way we set this up. Let me choose the right marker here. Is that AD, okay, over DB equals CA over CB. There's the proportion. In other words, when I have an angle bisector in a triangle, we know that the point of intersection here, D, isn't exactly in the center of segment AB. That is not the midpoint of AB in most cases, because it's an angle bisector. But it does divide this third side, this side AB, proportionally, in that if CA is shorter, then AD is shorter. If CB is longer, then DB is longer. So it divides that third side proportionally according to the other two sides of the triangle. And when we set up our proportions, there are a couple different ways we can set it up. Of course, you see one of them there. The other thing we can do, and again, I'm just going to kind of draw. Ooh, that didn't work out so well. So let me try again. Let me actually use a straight line. How about that? There's a triangle. There's an approximate angle bisector is right there. Okay. There's the angle bisector. And if I call this A, B, C, and D, we can set up our proportion a couple different ways. I can say A over B equals D over C, being consistent. So the whole side over the part side, whole side over the part side. Or I could set up my proportion short whole side over long whole side equals short part side over long part side. A over D equals B over C. It doesn't matter which way we set it up, because notice either way, when I cross multiply to set up my, or to solve my proportion, I wind up with AC equals BD. So both of these lead to this next statement. And solving that's pretty simple. Now some people even forego the proportion. Just remember that this side with this times this part equals this side times this part, no matter how we set it up. So they go straight to this equation, which is perfectly acceptable as well. It's just another way of expressing the same idea. So if you want to just go straight to the multiplication rather than setting up the proportion, that's perfectly acceptable. Let's take a look at this in action. First off, a review from yesterday. I have a couple problems. And again, these are pretty self-explanatory with the parallel lines. They set up exactly how you would expect. Here I'm going to take 16, and I could take 16 over BD here, which is what I'm solving for, or I could take 16 over 40. It really doesn't matter how we set it up. I'm going to take the 16 over 40 and then be consistent with the second one. This is going to be x over 30. I just can't kind of go around this going with 16, 40, 30x. I have to be consistent in the way I set it up. That's the most important thing. So 40x equals 16 times 30. That's a pretty big number. 10 times 30 is 300. 6 times 30 is 180, so that's 480. And divide by 40, and I get x equals 12. Here I can do the same thing. I'm going to set up 16 over 15 this time equals x over 18. They wanted JM, so x is right there. And again, I just cross multiply and solve that. That's not going to come out to a nice number. But again, realize we aren't always going to get nice numbers. We're going to see that more often now where we're getting not nice numbers. We're going to get fractions and decimals. So I take 16 times 18. I think I'm going to do this. Hold on. Here we go. 16 times 18. Okay. Divide that by 15. In the end, I get 19.2, or 19 1/5, or if you just want to leave it as a fraction, it's 96/5. Okay, so that happens. We'll do 6, and then we'll come back and let you do number 5 as your work here. 6, now this one's going to set up as a proportion. So I want you to notice something very carefully. YZ and ZX are exactly the same length. So when I set up my proportion, I get 4 root 2 over 4 equals something over 4. And obviously, since they have the same denominator, we have to have the same numerator. I'm sorry, y that was. So y must also equal 4 root 2. Don't overcomplicate things. If you get the same, if these are the same, then those have to be the same. Okay? Since these two are the same, then these two have to be congruent to each other as well. This one's a little more tricky, and I'm going to leave it to you to find the value of x. One last problem. This one's a little bit different because notice I don't have anything listed for QR here. I don't have anything listed for QR. I want to solve for x. So how am I going to do that? Well, what we're going to have to do is we're going to have to find a way of finding a value for QR. Now, I could just say that equals y, but what happens? When I set up my proportion, I get 7 over y equals 13 over x, and when I cross multiply, I still have two variables. That doesn't work very well. So what I'm going to have to do is use the information I'm given to create an expression for QR. And what I can know for sure is QR here is the whole thing, 15, minus what we've already used up, x. So I can express that in terms of x by saying that's 15 minus x. And now I can set up my proportion. And I'm going to do this, instead of setting up a proportion, I'm going to go ahead and do this, go straight to the products. The side times the angle opposite equals the side times, I'm sorry, not the angle opposite, the side times the segment opposite is the side times the segment opposite. Which would have resulted, if I set up my proportion, notice when I cross multiplied, this is what I would have gotten to. So if you don't want to go directly to that, you want to set up your proportion, that's fine. It's just another step. A little work to do, 7x, 13 times 15 is 150, plus 45 is 195, minus 13x. Adding 13x to each side, I get 20x equals 195. So x equals 195 over 20, which does reduce. Sorry, that's not my calculator. Try that again. Uh, 39/4. And sure enough, not a whole number. That's okay. We still found the length of the side. So the trick there, again, is recognizing that since I'm given the whole side, I'm going to have to set up a variable expression using the information I'm giving. Whole side minus part already used is what remains. That's just a good skill to develop in modeling things mathematically. All right, that's all we have for today's podcast. Don't forget we will be having a review coming up, followed by the Chapter 8 test, and then we'll be on to Chapter 9. See you in class.